Well, hello. We are going to tackle question number 2 on the mathematical AI paper 1, 2023 version. And so this is going to be a chi-square problem. And so let's get right into it. A company that owns restaurants wants to determine if there's a difference in the quality of the food cooked for 3 different meals: breakfast, lunch, and dinner. Their quality assurance team randomly selects 500 items of food to inspect. The quality of this food is classified as perfect, satisfactory, or poor, and the data is summarized in the following table. So here's the table. You can see the breakdown. It is a 3x3 matrix, and it is broken into quality of food and the time of meal: breakfast, lunch, and dinner. Quality, perfect, satisfactory, or poor. And you look at the marginal data, and you can see that the total in the lower right is 500. And so we get into the next part of the question. So a chi-square test at the 5% significance level is carried out to determine if there is significant evidence of a difference in the quality of the food cooked for the 3 meals. So that word difference, I highlight that and I think about that, and it points me to a chi-square test of homogeneity, which is interested in, is there a difference? And then continuing on, the critical value for this test is 9.488, and then the hypothesis tests are given. The null hypothesis, the quality of the food, the type of meal are independent. Oh dear. The alternative hypothesis, the quality of the food type of the meal are not independent. So this is a problem of semantics for me, because I feel like we have some inconsistency, and the inconsistencies come in more the semantics, or how we're communicating, or how we're analyzing the problem. So the question is very clearly a difference, which is chi-square test of homogeneity. And the word difference is really key in the analysis. And then the next one is independence. And a chi-square independence test, although it's mechanically and calculation-wise the same test, if you're looking at just the numbers, but this is analysis, and this is high-level communication analysis. Like IB, we need to do a better job of specifying the type of test that we are covering right now. Is this a chi-square test of homogeneity, or is this a chi-square test of independence? And I'll say another name for the chi-square test of independence is the chi-square test of association. And it's wondering if the variables, in this case, meal and quality, time of meal and quality, are they associated with each other, or are they independent? And independence really means that they have no influence on one another. So that's the idea, is one variable, the time of day we eat the meal, and the quality are not influenced by each other at all. And so this is the start of the chi-square independence test. And because the null hypothesis and alternative hypothesis are clearly chi-square test of independence, that's the language that I'm going to use. I want to say, though, that in IB language arts, you would never be able to give a thesis statement and then to give a conclusion that doesn't match the thesis statement. That would never be acceptable, and that shouldn't be acceptable here either. So I'm going to ignore that for now and just get into the chi-square test of independence. So here's my calculator, and I'm going to go to the matrix and to edit. And look at that, I've already put in my matrix. So it's a 3x3 matrix. Let's check 101, 124, 7, 68, 81, 5, 35, 69, and 10. Okay, that looks pretty good. Now I think we're ready to go to stat and across the test. And this is going to be not the GOF, that's the chi-square goodness of fit test, and that's a different one. Here is the chi-square test, and it's the same for independence or homogeneity, because like I said, the calculation or the numbers, the mechanics are the same between the independence and the homogeneity test of chi-squared. So here goes. So what I'm going to do is call my matrix A, that's what I named it, is my observed values. That's what I plugged into the calculator. And then it's going to go ahead and compute all my expected values and plug those into a new 3x3 matrix B. So let's go down to a calculate, and I think we're ready. All right, so I get an answer here of chi-square. So my chi-square value is 11.02, 11.02, 1, 2. I'll go a few extra digits. I'm also giving my p-value is equal to 0.026. And my degrees of freedom are equal to 4. And if I do take my 3x3 matrix and I say, oh, the column is 3 minus 1 is 2, and the horizontal is 3 minus 1 is 2, 2 by 2 is 4. So that does match this particular 3x3 matrix. So the rows and columns are used to determine the degrees of freedom. And then as we move on down, I'm going to make sure that I indicate that I got these values using the GDC, the graphics display calculator. I have a couple things that I can analyze. And first off, the chi-square, I can compare the chi-square to the critical value that was given. Critical value is 9.488. I can see that the chi-square I calculated is more extreme than 9.488. And then I can also look at the p-value, and the p-value is 0.026 or 2.6%. And we're comparing that to what's called alpha, or this is a 5%. Alpha is 5% for this problem, as was indicated previous, 5% significance levels. So what I'm going to do is I'm going to use both of those. I'm going to cover all bases and just make my analysis rock solid. And I'm going to say that since the chi-square that I calculated is greater than the critical value, I'm going to give some specifics, and I'm going to say that 11.02 is in fact greater than the critical value that's given is a 9.488, 9.488. Maybe I'll go one more digit and say 11.021 is greater than 9.488, and my p-value is greater than alpha. I'm going to cover all bases, and I said that wrong. My p-value is less than alpha. And since the p-value is a lower percent probability at this particular chi-square value, and p is less than alpha, let me put the actual values. 0.026 is less than 0.05. All right, so I'm going to say that since those two things are true, since my critical value was less extreme than my chi-square, and because the p-value that I calculated was also more extreme than alpha, it's 2.6%, I will reject the null hypothesis, and I'll just call it the HO. I will reject the HO and have convincing evidence that. And then I look at my H1, and I'm going to really use that language of independence. In this case, not independence. The quality of food and type of meal are not independent. That the quality of food and the type of meal are not independent. And I think this is a 4-point problem, so I think that's about it. But I do question the design of this question, and I would like for IB to do a better job in the future, specifying and making sure that the communication of the question matches what's expected for the communication of the test takers, the exam writers. And so that's it for that question. Not much there. Hopefully that's a question that we can finish and answer much quicker than I just did, but I just had to talk about like a whole lot of different ideas and thoughts around this particular question. So thank you very much. And I hope that this was helpful.